All right, good afternoon. This is Mr. Mays. It's the 16th of November. This is for Geometry, Chapter 4, Section 4.3. We're rotating shapes. Now, what you'll notice here is that we have this core concept block on page 191 that pretty much sums up what we're trying to do. If you will notice, these are the big three rules. We're only going to rotate 90 degrees, 180, and 270 degrees. Now note what happens to point A in quadrant 1. 90 degrees shifts it counterclockwise into quadrant 2, and when that happens, the values of the x and y trade places and the y becomes negative. When you rotate it 180 degrees, we move over 2 quadrants, and notice that the values of A and B change signs. And then if we rotate it 270 degrees, that moves us 3 quadrants. We move from quadrant 1 all the way to quadrant 4. And that puts us at opposite B and A. They trade places and the A becomes negative. So you get the Y value goes into the X slot, and then the X changes signs and goes to the Y slot. So what I've done here is I've got a couple of examples for you. And I did a problem, made something up, and I rotated it 90 degrees. Now notice the rotation, 90, 180, and 270. They are all about the origin, and they all rotate counterclockwise. So here's the rule for a 90. The rule says that for every value x and y, the y goes to the x position and its sign changes, and the x goes to the y position and it remains the same. So here's my shape. I started off with A, B, and C, a triangle. So therefore, point A at 2, 1 went to negative 1, 2. B at 8, 6 went to negative 6, 8. And C, 4, 8 went to C prime, negative 8, 4. Now notice, that's what it looks like. Now I took the A and the A prime, and I compared these 2 points. If you start at the origin, and if you apply a slope of up 1 over 2, this would have a slope of 1/2. Now look at A prime. It has a slope of negative 2 over 1. Notice that these slopes of A and A prime, if you go from the origin, if you draw a line, and you go from the origin and you draw a line, they are opposite reciprocal of each other. So a line that would connect A prime to the origin and A to the origin, they would be perpendicular, hence the 90-degree rotation about the origin in a counterclockwise fashion. You can do the same thing with point C. If you come over here and you draw a line from C prime to the origin, and from the origin to C, you'll notice that their slopes are opposite reciprocals. They rotated 90 degrees counterclockwise about the origin, as did point B. So that's the rule for a 90-degree rotation counterclockwise about the origin. There's the rule. Okay? Now, let's look at 180-degree rotation. So 180-degree rotation, I started off in quadrant 2 this time with A, B, C, and I rotated it 180 degrees about the origin. Notice that I went 2 quadrants, 180 degrees. Okay? So here's how that worked. Here's the rule. For every value x and y, they simply change signs. Okay? They simply change signs. So if A is positive, say it's a negative 3, goes to a positive 3. So here's my 3 points. So I have negative 2, that's A, 180-degree rotation about the origin in a counterclockwise direction. We'll put it at A prime at 2, negative 2. B will go from negative 6 to 6. Same thing again, counterclockwise rotation about the origin, 180 degrees. We'll go to 6, negative 6. And C prime, I forgot the C prime. There we go. C prime, 7 to negative 1. Okay, and it'll look something like this. Notice, 180-degree counterclockwise rotation. A to A prime, B to B prime, and C to C prime. Now there's an interesting thing about 180-degree rotation. If you look at this, this is what we had. Notice that we started over here, quadrant number 2, okay, quadrant 2, and then we went over to quadrant number 3. I can take the same shape, I can reflect this about the y-axis, and then reflect it about the x-axis, and I will wind up in the same position as if I had rotated it 180 degrees counterclockwise. And if you think about it, if you were to rotate it clockwise or counterclockwise, flip, flop, or go around. And if you look at what the rules did, you will find that you will wind up in the same place. Reflection about the y-axis took me from here to here. Reflection about the x-axis took me from here to here. A counterclockwise rotation of 180 degrees about the origin would put me here also. Anyway, something to note. All right, and then finally a 270 degree counterclockwise rotation about the origin. Again, I started over here in quadrant number 2, and 270 degrees put me in quadrant number 1. Now, here's the rule. It says that for a 270 degree counterclockwise rotation about the origin, for every x and y, in this case use a and b, then you get a b and a negative a. So the y position goes to the x slot, and the x slot goes to the y position, and its sign changes. Okay? So, here's your rules again. Here's your rules. Page 191. Might want to know those. So, that's what happened. Now on this one here, notice that I drew from the B prime to the origin, and from the origin to B, it forms a 90-degree angle. If you go from here 270 degrees in a counterclockwise rotation, you will wind up right here. And same with from C to the origin and C prime, and A to the origin to A prime. 270 degree rotation puts me into quadrant number 1. So those are your 3 basic rules for a 90, 180, and a 270 degree rotation counterclockwise about the origin. Okay, so let's look at just a couple of problems out of this section. The rest of them are pretty self-explanatory, you know, number of lines of reflections and all that's pretty easy. So I decided to do number 16, and then I want to look at how all of this works. So what we had to do is we started off with triangle LMN. It points the vertices 1, 6, negative 2, 4, and 3, 2. And first we reflected it in the x-axis, and then we rotated it 270 degrees counterclockwise about the origin. So here we go. So we went from LMN, we reflected it about the x-axis, flopped it down here. Notice all the values here. The x values remained constant. And if I was 2 units above the x-axis, now I'm 2 units below the x-axis. If I was, 6 units above the x-axis, now I'm 6 units below the x-axis. If I'm 4 units above the x-axis, now I'm 4 units below the x-axis. There's my reflection in the x-axis. And then I took this shape and I rotated it 270 degrees counterclockwise about the origin. So, here's my reflection in the x-axis. And then, remember, 270 degree rotation. There's my rule. L prime went to L double prime. Notice the notation. I have 2 movements. I started here. I went to here, notice the prime, and then I went to here, my second image, I went to N prime. So here's my pre, next image, the next image. L prime, L double prime. Okay? So I reflected it, and then I rotated it 270 degrees counterclockwise about the origin, and that's where I wound up. So I did 2 motions here, a reflection and then a rotation for problem number 16. So that's what I did for that one. Okay. You have an assignment out of this section, 4.3. And then, of course, you know, we do axes of symmetry. You know, what's the degree of rotation for those axes? Problems like this. But anyway, here's your exercise set. We do the average set, okay? Now, don't do 35 through 38. Notice I have a line through those, so don't do those. Skip those. And then don't do that inset either. Don't do these. So just do 1, 2, and then 4 through 32 even. Now, I've got notes posted on those, so they should be okay, should be good to go. And if you have questions, please feel free to shoot me an email or attach a comment to your Google Classroom, and you should be in some pretty good shape. Okay, we'll talk to you guys tomorrow. If you have questions, please ask. All right, thanks. Bye.